Mhm.
For the internship activity, do you think it's beneficial?
Yeah, it's always beneficial to go to those things.
Because I look at the companies,
Mhm.
and there's not many like. You can do.
I think it's always good to go because you never know. Because even a lot of other companies, they have engineering divisions. And if anything, you can use it as a practice, you can talk to recruiters and do, practice presenting yourself. And, because that's always good. And that's always kind of a good thing to get practice with.
Because I feel like if it's funny, I'm looking for like a mechanical engineering job.
Mhm.
But like I don't know their company and I go to them and I'm applying for mechanical jobs.
Uh-huh.
But they're not really interested in hiring.
That's fine. I mean, that's up to them to determine if they want to hire you or not. But, the worst thing that could happen is when you apply for a job or you talk to recruiters, if they say no. But then if they do, then you're in the same position as you were before, right? And so it's only the time that it takes to do that. But most of the time it's really fast. So yeah, go for it. Mhm. I don't have any more this week, but if you want to meet tomorrow, you can send me an email and then we can make an appointment to meet. If not, my next office hours on Monday morning. Okay, I mean, we have some time right now if you want to ask.
Solving the number two,
Mhm.
I subtract the rest to go to the center, right?
Yeah.
So 30,100 this.
Yeah.
And then I plug a number and then you put an answer. So I kind of drew like 60% and 7%.
Yeah.
And it still doesn't give me the right answer. So I got 6.683.
Okay.
If it's close, then maybe fine.
Let me double check that. There might be an error with my numbers.
Okay.
Yeah, if you can send me a screenshot of your work and then I can check it because I don't have a solution with me on.
Okay.
So yeah, just send me. I think it's just an issue with so I'll go ahead and double check everything. I'll double check my own work and then I'll let you know if there's a mistake.
Okay. I don't know how to solve. It's kind of hard.
Okay, so for this one, I gave you kind of the year by year.
Yeah.
And so what I wanted you to see from this is to break this down. So you see the maintenance, it goes up by 4,000 every year.
Right.
And so there is an added grading for the maintenance. And then for the
Oh,
revenue, it's going up by 50,000 shares, there's a grading too.
Right.
And so you need to account for that.
Oh.
Yeah. And so you're gonna do the same thing as the last one. You're gonna have option A, option B. And then, but then you're gonna include those gradings together with that table. So just like you did the last problem, but then include these.
Okay. Makes sense.
Yeah.
And this one I should solve the 2D first. And then also all the numbers. The answer was 1.15. And I got 1.16.
That's cool.
Okay. And then in this problem, so I have the ratio for 1.83 for both S.
Yep.
And 1.57 for both L. So I compare with that and we find the ratio 1.16 and the lowest one is good.
Well, so I mean, if this one, so is this the difference between the two?
Yeah.
So that's the difference between two. If this is higher than one, then you're going to go with the more expensive option.
Oh,
yeah. So it's very similar to how you did the rate of return. And so you look and see this. If it's greater than one, then it's better to buy the more expensive one. That's a better use of money.
better expensive one.
Yeah. So the one with the higher initial cost.
Oh, so I should change it. I think I have to solve this.
Yeah, give those ones a try first. So
Yeah, I'll try. Maybe if I have a question, then I'll.
okay, yeah. All right, it's 1 o'clock. Let's go and get started. All right, good afternoon, everyone. How's everyone doing today? Good to hear. It's cloudy, so it's nice. Feels like the sun's not trying to kill us for once, so that's good. We had it for the whole week. Okay, so the plan for today is we're going to continue where we left off on Tuesday, and so we were talking about economic life and replacement analysis, and so we're going to continue on with that. Okay. Remember, homework 4 is out there. I believe it's due next week, and so definitely start working on it if you haven't yet, because it is a longer assignment compared to all the other ones we've done so far. And if you have any questions on it, please don't be afraid. Send me an email, tell me what you're working on, or come to office hours on Monday, Wednesday, or Thursday. All right, and so that's all for my announcements. Are there any questions I can answer before we get started for today? Okay. All right, let's go ahead and continue. All right, so let me just scroll up just a little bit here, just so I can have this kind of graph. And so this is the graph I drew kind of at the end of class last time. And so, this whole chapter on replacement analysis is kind of answering the question of, how long should we keep an asset before we should sell it? Okay. Because up to this point, we've kind of been working under the assumption that we should just use our machines, we should just use everything until it breaks. But oftentimes that's not the most economic thing to do, because the longer you keep an asset, usually the maintenance costs are going to go up, its performance is going to go down, and so there's usually kind of a sweet spot in between when you first bought it and its end of life, when it's the best time to sell it. Okay, and the way that we compute that is by computing basically an annual cash flow analysis of that part. So we compute, based on how many years we keep the part, what's the minimum cost of ownership. Okay, and that's kind of what we're computing here with this EUAC. Right. And so what we're saying is that, based on how much this asset costs and, based on how much it's going to cost to maintain it every year, we can compute, this equivalent uniform annual cost of ownership, if you were to keep it for a certain amount of years. Okay. And in most cases, you're going to see a trend like this, where, the EUAC starts off fairly high, but then as you use it for a few years, that cost is going to go down until it reaches a minimum. And then after it reaches that minimum, it's going to come back upwards. Okay. And so, we're looking at situations like that. And so we did an example kind of to end the lecture on Tuesday. And so today, we're going to throw some additional complication into this. We're going to see how we take care of salvage values and overhauls, and excuse me, and see how that affects our calculations. Okay. All right. All right, so we were working on economic life calculations, and now we're going to add salvage values and overhauls. Okay. So salvage values and overhauls, these are concepts that we're familiar with, and so we've tackled these just from a cash flow standpoint. But now we're going to see how they affect our replacement calculations. Okay. All right. All right, let's talk about salvage values first. Okay. And so remember, salvage values, this is the term that we use to indicate, the amount of money that we get for selling the asset, or for kind of, selling the parts. Okay. Okay. Usually this occurs at the end of life, and so when we use up the entirety of the part, we usually sell. Maybe we either take it apart, we sell the parts, or we sell it to someone else that can use it. Okay. And so when we're talking about economic life, of course, this means we're probably going to sell it early, and so we're not going to take it all the way up until the end. We're going to sell it at some time. Okay. And so the amount of money that we sell it for is going to be somewhere in between, the amount of money we paid for it and its ultimate salvage value. Okay. Okay. Right. And actually, we just got done talking about this in our tax calculations. So we know that every year that we use a long-lasting asset, it's going to depreciate in value. Okay. And so when we're talking about economic life, that decrease in value is something that's important. And so basically what we can consider is that loss in value, or that depreciation, that is kind of an additional cost that we incur by keeping that asset for one more year. Okay. Okay. And so in addition to the rising maintenance costs, in addition to the drop in performance, that's something we have to always keep in mind, is that, the salvage value is dropping. And so that's basically like an extra cost. Okay? It's not exactly money that we're paying out, but it's money that we're losing out on by not selling it sooner. Okay, so that kind of adds another complication. Okay. All right, let's review overhauls now. So overhauls, remember, these are the terms that we use to indicate any kind of major one-time cost or irregularly timed cost throughout the life cycle of the part. Okay. So usually this takes the form of some kind of major maintenance. And so, that's something we have to account for. And so when we're accounting for this in economic life calculation, there's kind of two aspects, right? And so on the one hand, we know overhauls take place, sometime in the middle. So it's not something that's occurred initially, and it's not something that occurs at the end, but it occurs sometime in the middle. So when we're doing economic life, we have to ask ourselves, when we're doing kind of a year-by-year analysis, we first have to ask, if we sell the part at this time, if the overhaul is going to take place yet. Okay. Okay. Because if it's known for a part that, we have to incur an overhaul cost in, say, year 6, but then if we sell that part in year 5, then it's not even going to take effect. Okay. And so when we're doing kind of our year-by-year analysis for economic life, what you're going to see for overhaul is that there are going to be a lot of zeros. And so those zeros indicate the fact that, even if we sell the part before the overhaul takes place, we're not going to incur any cost. Okay. But for the cases where we do incur that cost, we have to do, a non-standard cash flow conversion. Because remember, when we do economic life, we're basically doing annual cash flow analysis. So what we have for overhauls are kind of a one-time future sum. And so whenever you convert a one-time future sum to an annual cash flow, you usually have to do it in a non-standard way. Okay. And so here's the formula that we're going to use. Okay. So we have EUAC. Okay. And this is specifically for an overhaul. Okay. This is going to be equal to F, where F here is the value of the overhaul cost. First thing we're going to do is we're going to take this future sum and then kind of convert it into the present day. Okay, so this is going to be a P over F at interest rate I. Okay. And then the year that we're going to use for it is the time when the overhaul takes place. Okay. So usually this is fixed. And so, when you're doing a year-by-year analysis, the overhaul happens in a fixed year. So it's always in year 5 or always in year 6. And so that number there is fixed. Okay. And then we need to convert this present sum into a uniform series. And so this is the second conversion that we're going to do. And so we have an A over P. And then we're going to plug in the interest rate I. And the end value here is just going to be whatever the present year is. Okay. And so this is the one that's going to change based on what row you are in the table. Okay. Okay, so that's the current time under consideration. So I'm going to go ahead and box this. All right, so that's the non-standard conversion that you're going to have to do for an overhaul. Okay. All right. And then to kind of account for the first bullet point there, where we only incur this cost if we kind of pass that over time, and so if end current is less than end overhaul. Okay. Because if the current time is less than when the overhaul takes place, then it basically hasn't happened yet, or it won't happen. The EUAC of the overhaul is going to be 0. Okay. So that's important to keep in mind. And so we're only going to incur this cost for those years. Okay. Okay, so the next thing I'm going to do is I have an example here which kind of has both of these in action, and so we'll see how to account for salvage values, and we'll see how to account for overhaul costs in our calculations. But before I do that example, are there any questions on this? Okay. All right, let's go do an example. Okay. All right, so for this example, let's say that we have a machine with an initial cost of $18,000. Okay. The maintenance on this machine is going to cost $900 per year. And then each year after the first one is going to increase by $500. Okay, so just like the examples we've been doing so far, the maintenance costs are going to go up each year as is normally the case. Okay. All right. And so let's talk about the salvage value. And so the salvage value, we lose a lot of value on this right away. Maybe this was depreciated using bonus depreciation. Okay. And so the salvage value after the first year, and so if we kind of sell it after 1 year of use, it's going to be $5,000. Okay. But if we continue to use it after that first year, the salvage value is going to decline by 10% each year. Okay. And so the longer we keep it, the less it's going to be worth on the market. Okay. All right. In addition to this, we have an overhaul cost. Okay, and the overhaul is going to take place in year 6. An overhaul cost of $3,240 will be incurred. All right, and so if we assume an interest rate of 8% and the total useful life of this part is 10 years, let's compute its economic life and minimum EUAC. Okay. All right. And so, this is kind of an extension off the example we did last time. And so, we have all the same elements as before, except now, it's, we have a lot more stuff to do. And so, the big things that we're adding here are the salvage value and the overhaul costs. Okay. And so let's see how we can account for those in our calculations. All right, but just like we did before, the way we're going to organize our results for this problem is to make a table. Okay. And remember, what we put in that table is we take each of the main cash flows that are in this problem and we convert them to an EUAC. Okay, and so let's take all the cash flows that we see here and convert them to a uniform series. Okay. So let's start with the initial cost. All right, so our initial cost is $18,000, and so that is a present sum. And so to convert that to a uniform series, we need an A over P conversion. Okay. Our interest rate is 8%. And we're going to evaluate this at different values of N. And so for the N value, I'm just going to put N current. Okay. Okay, so for the maintenance, we have a couple aspects to the maintenance. And so we have the baseline value of 900 per year. Okay. That $900 per year is already in uniform series form, and so we don't have to convert that, but we do have to convert the gradient. And so we know that the maintenance costs are going to increase by $500 each year. And so that 500 is a gradient, and so we're going to do 500 A over G, 8%, and N current. Okay. All right, next we have the salvage value. So we know the salvage value here is a starts at $5,000. Okay. But because the salvage value is a benefit, right? And so we don't have to pay money to sell it. When we're converting the EUAC, we're actually going to make the salvage value negative because it's basically an opposite of a cost, right? And so that's kind of an important key thing. We know from the problem that the salvage value here is going to decline by 10% each year, okay? And so to kind of represent that mathematically, I'm going to do it like this. And so, we know that if something is declining by 10%, another way to compute that is just to multiply by 0.9, right? And so this is a decrease. Okay. So multiplying something by 0.9 means that you decrease the value by 10%. But that decrease of 10% is gonna happen every single year. Okay. And so we need to multiply by 0.9 for each year that we are going to decrease its value. And so one way that we can do this is just raise the 0.9 to the n power. Okay. And that's n current. Okay. Okay. And so if we keep this asset for 2 years, that means its salvage value is going to decrease by 10% twice. And so we compute that by doing 0.9 times 0.9. And so that'd be like 0.9 squared. Okay. Although I'm going to make one small adjustment here, because we know that the salvage value is actually 5,000 at the end of year 1. And so we actually don't want to multiply 0 by 0.9 for n is equal to 1. And so I'm just going to do an n current minus 1 there. Okay. And so that tells us that the value is actually going to start decreasing in year 2. Okay. So of course, there's no formula for that. And so, what you'll see is that for, especially in the homework, the way the salvage value decreases kind of changes on a problem by problem basis. And so I think one of the parts that's I think tricky for people is how to represent that mathematically. And so sometimes, if it decreases by a fixed amount each year, you can actually represent it as a gradient. That's one way to do it. Or another way, if it decreases by a percentage. And so just like this one, you can do it just by multiplying like that. Okay. Right. So let me go ahead and so I know there'll be questions about this later. So the reason I kind of add this is because for this problem, the value decreases by a percentage each year. Okay. And so when you're doing problems like this with a salvage value, you have to kind of see, how is the salvage value decreasing? And so if it's decreasing by a percentage, you can use something like this. But if it's decreasing by a fixed amount, you're going to have to model it in a different way. Okay, and so that's one thing you can have to decide based on what the problem is saying. Okay. All right, but we're not done yet. And so remember this salvage value is just a single future sum. Okay. Luckily for us, this future sum is taking place at the very end of the period. Okay? And so if we choose to sell in a given year, that salvage value is going to occur at the end of the cash flow diagram. And so this is just a standard conversion. And so we just need to standard convert the F to an A. So we have an A over an F, 8%, and N current. All right, any questions on how I got this formula so far? Okay. All right. And so the last thing we have to take care of here is we need a column for the overhaul cost. Okay. All right, and so we know the overhaul takes place in year 6. Okay. And so we have two different options for the overhaul. Okay. Okay, and so if we sell the asset before year 6, you know that we're not going to incur the overhaul because it hasn't happened yet. And so if N current is less than 6, then the overhaul cost associated with that is 0. Okay, but if N current is greater than or equal to 6, okay. And so in other words, we keep the asset past the overhaul date, then we have to account for it. And so that overhaul cost is going to be 3240, which is the numerical amount of the overhaul cost. Okay. And we're going to do our non-standard conversion. So I'm basically going to use this formula right here. Okay. And so we have P over F. The I here is 8%. Okay. This conversion factor right here uses an N of the overhaul. And so in this case, the overhaul takes place in year 6. Okay. And then we convert that to a uniform series, since we have A over P, 8%, and then N current. Okay. All right, and so that's our two cases for the overhaul. So, if it hasn't happened yet, we don't account for it. But if it does, then that's the formula that we're going to use. Okay, all right. So now that we have all these conversion factors, all these conversions done, we can now put them into a table. Okay. All right. So just like last time, I'm going to make columns for each of the cash flows. Okay, so these are all the columns that we have. So we have a column for the year, of course. And so let me go ahead and label that down. Okay, and so I'm going to make 10 rows here because the problem says that the maximum amount of time that we can keep it is 10 years. Okay, so that's the useful life. I have a column there for the initial cost, column for the maintenance, column for the salvage value, one for the overhaul, and finally the EUAC, which is going to be the sum of all those different columns. Okay. All right, and so once again, when you're doing these problems on your own, you don't have to make all these columns here. I think it helps. I think it's really helpful to kind of see how each of these columns evolve over time. But technically, the only thing you need to actually solve the problem is just the EUAC. And so if you want to do this kind of all internally, you can go ahead and do that. But if you're not getting the right answer, it's a lot easier for me to check your work if you kind of list out everything like this too. Okay, so pros and cons. Okay, so let's go ahead and start listing these down. Okay, and so the values that I'm getting in this table are going to come from the formulas that we've defined here, but I'm going to plug in different values of N. Okay, so we'll start with the initial cost. And so for the initial cost, we have 18,000 times A over P, 8%, and N. Okay, so if we plug in N is equal to 1, then what we get is 19,440. Okay. We plug in N is equal to 2, we have 10,094.40. Should have made this column wider. Okay, for 3 is 6984. Okay, for 4 years is 5434. And I'm just going to go straight down. Okay. And remember, what you should notice for the initial cost is that the longer that you keep it, the initial cost EUAC is going to go down, or the yearly cost of ownership is going to go down for the initial cost, right? And that makes sense because remember, the longer that we keep an asset, the more kind of time that we spread out the initial cost for. And so, this is consistent with what we believe. And consistent with what I believe too. And so, so I tell my wife every day, it's like, if I don't throw the shirt away, then I don't have to buy a new one. I don't care that it has 8 holes in it. I can still wear it. Okay, so that's the initial cost. Okay, so you can see that's going down. Now let's do the maintenance. And so we know the maintenance cost is going to start at 900 for year 1, and then it's going to increase by 500 each year after that. Okay, but remember, we're converting this to an EUAC, and so that's why you see the increase here is not going to be exactly. It's not going to be exactly 500, but it is going to go up every year. So that's all of the maintenance values. Okay. And, by the way, I know a lot of you are writing this down, but, I'm taking this example just straight from the lecture notes. And so if you kind of just want to chill and just kind of look at the results and then just kind of, look in the notes and just confirm these numbers, I think that's probably a better, something better to do. But if you want to keep writing down, that's by all means. Okay. Okay. Now we have the salvage values. And I say that just because I'm going to go a little bit faster, just so, just so we can kind of go along. So. And so you can see for the salvage value, because remember, we're losing 10% value each year, that the salvage value is going down the longer that we keep it, which, again, makes sense. Okay. Now we get to the overhaul cost. And so remember, for the overhaul cost, for the first 5 years, it's going to be 0 because it just didn't happen yet. Okay. It's only after year 6, that's when the overhaul cost first happens. That's when we start to see these things. Okay. And so the overall cost is interesting. And so it's very similar to the initial cost, where the initial cost starts out really high and then goes down the longer you keep it. The overall cost behaves kind of similarly. So you get kind of a high value in the year that it happens, and then the longer that you keep it after that, that impact goes down. Okay. So of course, we see a big spike in year 6, and so that's a 442 extra in terms of yearly ownership cost, but then that goes down. Okay. All right, and so finally the moment of truth. And so what happens when we actually add these across? Okay, and so the total yearly cost of ownership can be found in this column here. So 15,340. 9071.3. Okay. And so those are all the yearly EUACs. Okay. All right, and so we're looking for the minimum one here. And so I think when most people read kind of this problem for the first time, you would think that the best thing to do would be to sell this asset before the overhaul cost happens, right? And so if we can get rid of this, if we kind of get rid of this this asset in year 5, then we don't have to worry about the overhaul. That's most likely the best thing to do. Okay. But if you actually ran all the numbers, you can actually see we end up with a lower EUAC in year 9. Okay. And so if we compare that to the EUAC in year 5, and so there are close, and so they're not too far from each other. But if we actually keep the asset past the overhaul cost and then run it all the way to year 9, that's going to be the minimum yearly cost of ownership. Okay. And so the economic life for this example here is 9 years. And the minimum EUAC is $5,681. Okay. All right, and so remember what the EUAC minimum, what that represents is that if we keep this machine for 9 years, then we're basically it's basically paying the equivalent of $5,681 each year to own that machine. Okay, but that's only if we keep it for 9 years. If we keep it for any other time, we're going to pay more per year to own that machine. Okay. All right, any questions on this example here? Okay. All right, and so, I'm about to move on to the next thing, which is replacement analysis, but I did want to mention a couple other ways you can modify this analysis, okay? And so in addition to salvage values and overhauls, one thing that's often taken into account for economic life is the chance of a major breakdown occurring, okay? Okay. And so I think, this is, and I mentioned this because I think this is the way that most people think about their replacement decisions. And so, if you think about your, if you think about your phone, maybe you kept it for 4 or 5 years and, you don't actually pay Apple or you don't pay Samsung anything to use it year per year, outside of your phone bill. But what you're thinking about is, what's the risk of something major happening to this phone and how much is it going to cost to replace it? Okay. And so you can account for this in an EUAC type of fashion, okay? Okay, and so the way that you can add the cost is you can take the amount of money it's going to take to repair that major breakdown. Okay. And so if you have to replace your whole phone, or, I think more commonly too, is that if you have to replace a major part in your car, okay? And so if you have to pay to do that, you know how much that's going to cost, okay? And then you're going to multiply that by the approximate percent chance that it's actually going to break down. Okay? And so you're going to add this cost to your calculations, right? And of course, the longer you keep an asset, it's going to be more likely that you're going to have a breakdown. And so generally speaking, this amount right here is going to go up the longer that you keep an asset. So if you just got a new car, maybe the chance of a major breakdown is basically zero. Not totally zero, but, very much zero. But if you keep the car, 10 years, 11 years, 12 years, suddenly this percent chance is going to go up, maybe 1 or 2% each year. Okay? So that's one thing that you could take into account. Okay? And then, of course, to include it into an economic life calculations, you have to convert it to a uniform series. And so this is just the one-time cost. And so just know that you have to convert this to an EUAC as well. Okay. One other thing that you can take into account into economic life is opportunity costs. And so, maybe there's nothing wrong with your current machine or current asset. But if you don't upgrade to a newer version, there's going to be some costs associated with that as well. So maybe, let's talk about this in an engineering point of view, right? So maybe you're thinking about replacing one of the manufacturing machines in your company. Okay. So maybe the old one that you have is still working fine, but the newer model can output kind of more parts and have more output than the old one. And so, each year that you keep the old one, that's kind of an additional cost that you're incurring by not, having that increased output. Okay, so that's kind of another thing that you can consider. All right, any questions on this? Okay. All right, so now that we know how to do economic life calculations, and so, now that we have an idea of, we have this part, now we have an idea of how long we should keep it, to maximize our finances. Now we're going to add the other piece to this analysis. And so now we're ready to do actual replacement analysis. Okay. All right, and so replacement analysis kind of goes one step beyond economic life. And so usually when you're doing replacement analysis, you have an existing asset, you have an existing machine, and you want to determine if it's economically feasible to buy a new one to replace it. Okay. Okay. All right, and so you have an existing machine, you have an existing asset, okay, and you're trying to determine, if it's better to just write it out, just keep using this machine until it rides off into the sunset, or is it better to replace it now before it gets too costly? Okay, and so to do this, we actually have to compute two different things. Okay, and these two things that we're going to compute are going to be compared against each other. And depending on which one's higher, that's going to tell us if we go one way or the other. Okay. All right. So one piece of this puzzle is what we have been doing, and so we are going to compute economic life and minimum EUAC. Okay. And we're going to compute this for the new part. Okay. And so this is, if we were to replace this machine with a new one, what is the new machine's economic life and what is its yearly cost of ownership? Okay. Right. So we've done that already. And so that's kind of one piece of the puzzle. Okay. And the thing we're going to compare it to is something that's known as marginal cost. Okay? And so the marginal cost is saying that we have this existing asset. How much is it going to cost us to keep this running for one more year? Okay. And you're going to compare these two. Okay. Right. And so if you determine through your analysis that the minimum EUAC and the economic life for a new part is less than the marginal cost for the existing part, then you should replace it. Okay. And so basically what that's saying is that it's going to cost us more to keep this existing asset going for one more year than it is to just buy a new one. Okay. But if it doesn't cost that much to keep it running one more year, and it costs more to buy a new one on a yearly basis, then we just keep the old one. Okay. Okay. And so we're just going to go with just whatever is known. Okay. All right. And so, we've done economic life. We've done quite a few examples of that. And so the next thing we're going to learn to do is how to do marginal cost type calculations. Okay. So let's go ahead and do that. All right. And so based on the definition above, we know that marginal cost is just whatever cost that we're going to incur by keeping the part or keeping the asset running for one more year. Okay. And so we know, of course, there's going to be things like maintenance costs and upkeep costs and things like that. Okay. And so that's going to be the first thing that you look at. And so if you have an existing part, the first thing you're going to see is what are the maintenance costs going to be for this upcoming year, and are there going to be any overhauls, and then that's going to factor into your calculations. Okay. But the other thing we have to take into account is kind of what we talked about at the beginning today, where if we keep this asset for an additional year, not only do we pay the maintenance and overhaul costs, but at the end of that year, if we do choose to sell it, we're going to sell it for less than what we have. Okay, so there's an additional loss associated with the fact that the part is going to depreciate in value. All right. And so the way that we can represent this, let me go ahead and draw just a very simple cash flow diagram. Okay. Okay. And so I'm going to kind of visually show you what's going to happen, if you choose to keep an asset for one more year. Okay. And so let's call this T minus 1, and we'll call this T. Okay. And so the T's could be any time, and so that's why I just did it arbitrarily. Okay. And so let's say that at time T minus 1, okay. Right. And so what I'm going to say is that if we sold the asset at T1, and so you can say that T1 is like today. Okay. And so if we sold the asset today, then the amount of salvage value that we get for that is S1. Okay. So that's the amount of money that we would earn if we sold it today. Okay. But if we choose to keep the asset, we're kind of forfeiting that S1. Okay. And so one way that you can represent that is we can say that we are incurring a cost of S1. Okay. And so this is basically saying incur cost of S1. Okay. And so we incur cost of S1 by not selling today. Okay. But if we were to sell it at a year from now at time T, Right, and so it's not like we lose everything in S1, and so, and so if we sell it a year later, we can sell it for a different value, S2. Of course, S2 is going to be less than S1, right? Oops. Okay. S2 is going to be less than S1 because, the asset is depreciating in value, but we do get some money back. Okay. And so let me go ahead and draw an up arrow here. And so we say that we obtain S2. Okay. But if we choose to keep it for a year, we're gonna incur all the usual maintenance and overhaul costs. Okay. And so I'll call this just for the sake of since I'm using symbols already. And so maintenance and overhaul, I'm going to call M1. Okay. All right. And so with this cash flow diagram in mind, we can compute what the marginal cost would be. Okay, so marginal cost is going to be S1. Remember, S1 is the old salvage value. So that's the salvage value that we would obtain if we sold it, before this year. Okay. I'm going to advance this forward 1 year. Okay. Because remember, we're evaluating the marginal cost at time t. Okay. Okay. Because if we chose to keep this, then 1 year ago would be 1 year in the past. Okay. And so that old salvage value, we need to increase its value by the interest rates. We multiply that by 1 plus I. Okay. From that, we're going to subtract S2. And we're going to add M1. Okay. And so in other words, the marginal cost of ownership, the first cost we consider is, kind of the opportunity cost that we incurred by not selling it a year ago. And so that's the S1 times 1 plus I. Okay. We also incur all the usual maintenance costs, so that's M1. But then we offset that by the new salvage value, which is S2. Okay. So if we were to sell it at time T, we would get S2 back. And so that would offset some of the marginal costs from the year before. Okay. All right. Any questions on this before we do an example? Okay. All right. So let's do an example to see how this is used in action. And so for this one, we're just going to compute marginal cost. All right. And so let's say that we recently purchased a machine, and it has the following stats. Okay. First, we have the initial cost. And so the initial cost of the machine is $25,000. The maintenance for the machine is going to start at $2,000 per year in year 1. Okay. But this is going to increase. And so the maintenance is going to increase by $500 per year. Okay. All right, we're gonna have an example here where we actually quantify the risk of breakdown. And so let's say that this company has already quantified, the risk of it breaking down, and it's already put into a number. Okay. This is going to be $5,000 per year for the first 3 years. And so for the first 3 years, they've quantified the risk and the cost of replacement. That'll be about $5,000. But then after year 3, that's when the breakdown risk is going to increase. And so this is going to increase by $1,500 each year after that. Okay, and so those are the main kind of numbers for this machine, except for its salvage value. I'll show you the salvage value in a second. But let me go ahead and define the interest rate. Okay, we're going to let the interest rate I is going to be 15%. We're going to assume we have a useful life of 7 years. Okay. And so at the max, the machine's going to last 7 years. Okay. And so what we want to compute. And so what we want to compute here is the marginal cost of ownership for each year that we keep this machine. Okay. And so of course, we don't have all the information yet, and so I saved this just because it's a little bit it's up a little bit of space. Okay, in order to fully do the marginal cost calculation, we also need to know the salvage value. Okay, and so in this problem, in this case, the salvage value decay is pretty simple, but I wanted to show you it in tabular form just so that you kind of know how to handle this. Okay, and so this table is going to show us, if we were to sell this machine at the end of each of these years, this is how much money we get for it. And so at the end of year 1, the salvage value is going to be 22,000. At the end of year 2, the salvage is 19,000. Year 3 is 16,000. Year 4 is 13,000. 10,000. 7,000 and 4,000. Okay. Okay. And so just like we did with the economic life calculations, and kind of everything after the midterm, the best way we can do these types of problems is to organize everything into a table. Okay. Okay. So let me go ahead and do that. All right, so we have 7 years here. Okay. And what we ultimately want to compute is marginal cost. Okay. And so our marginal cost equation is given here. And so to compute this equation, we need S1, which is the old salvage value. We need S2, which is the new salvage value, and M1, which are all the usual operating costs. Okay. So let me go ahead and make columns for those. And so we have S1. We have S2. We have a column for M1. But for this problem, M1 is going to include both the maintenance costs and the breakdown risk. Okay, because remember, we have that additional kind of wrinkle for this year. Okay. Okay. Okay, and then the last column there is going to be marginal cost. Okay. All right. And so you have to be a little bit careful filling in this table for these marginal cost problems, because the S1 and S2 columns are going to be very, very similar. Okay. And so to kind of know the difference between S1 and S2, it's useful to kind of look back at this table right here. Okay. So remember, S1 is the salvage value in the previous year. Okay. Okay. And so even though we're going to be writing the values for S1 for years 1, 2, 3, and 4, just know that the S1 is going to be one for the previous year. Okay. And so for instance, for year 1, right, from this table right here, we know that at the end of year 1, our salvage value is going to be 22,000. Okay. But that's not the value of S1. And so S1 is going to be whatever it was in the previous year. Okay. The year previous to year 1 is year 0. And so in that year, we just bought the machine. And so the S1 value for year 1 is going to be 25,000. Okay. Because that was the initial cost. Okay. Meanwhile, the S2 is the salvage value of the current year. And so this is kind of where you would input the table as you see it above. Okay. And so from the table above, you can see that the salvage value in year 1 was 22,000. And so our value for S2 is going to be 22,000, just like that. Okay. And then we get to M1. And so M1 here, that's going to be the maintenance cost. And so we know the maintenance cost here is $2,000 in year 1. But we also have our breakdown risk. And so the breakdown risk is an additional 5,000. And so the total value for N1 here for year 1 is going to be $7,000. Okay. All right. And then finally, we have the marginal costs. And so remember, the marginal costs, you have to be careful here, because remember, for the economic life, we just added right across the entire row. Okay? So we took each of the columns, we added it. But for this one, we actually have a formula. And so when you compute the marginal costs, make sure you use this formula that we have up here. And so if we plug in for the formula, what we get for this is 13,750. Okay. And so if we keep this, if we keep this machine from year 0 to year 1, that's how much cost that we would incur for that year. Okay, taking into account both the change in salvage value as well as the maintenance. Okay. All right, so now let's go to row 2. And so to row 2, first we fill in S1. And so S1 is the salvage value for the previous year. And so for the previous year, the salvage value was 22,000. And so we're going to put that there. And the current salvage value at the end of year 2 is 19,000. And then the M1 here, 7,500. Okay, so we're going to add all that together. We get 13,800. Okay. And so I'm going to go ahead and add in all the other numbers here. Okay, so those are all the salvage values. And if you notice, one thing about this table here is that, you know, the old salvage value for the previous year is just whatever was the current one in the row prior. And so if you want to check your work, just know that, you know, this relationship exists. So the S2 value of the previous year is just the S1 value of the new year. Okay, so you can kind of slide those down. Okay. And so that's how the M1 values are going to change. Remember, after year 3, we start to have increased breakdown risk. Okay. Okay, and so if we plug into the formula, this is what we would get. Right, and so you can see that, you know, the longer that we keep the machine, you know, we're losing more and more salvage value each year, and the risk of breakdown and the maintenance costs are increasing. And so each year that we continue to own it, then it's going to cost more and more and more. Okay, so this is pretty typical. Right? So normally for a marginal cost calculation, the lowest marginal cost should be in year 1, right? Because that's when the machine is the newest. Its maintenance cost should be the lowest. Its risk of breakdown should be the lowest. And so, you know, you should get a lowest marginal cost on year 1. Okay. All right. Any questions on this? Okay. All right. And so, you know, that's how we do marginal cost calculations. And so, you know, now we know how to do kind of both sides of the puzzle here. And so now, in order to do kind of a full economic life, or excuse me, a full replacement analysis, we need to also do an economic life. Okay? And so that's the next example. And so I'm actually going to do an economic life on the same machine here, but we do have only 4 more minutes. And so let me call it for here today, just because I don't want to start an example, because, you know, I'm going to have to rewrite everything on Tuesday anyway. So we'll end a little bit early today. And so if you notice, I brought the exams again today. And so if you haven't had a chance to pick up your exam, you can go ahead and do that. But if not, thank you guys for coming today. I hope you guys enjoy your weekend, and I will see you guys next week.
Thank you. Wow. A lot of people.
Yeah. Mhm. This will probably be the last day I take the entire stack of exams, and so if you want to pick up your exam after today, just let me know, and I can bring it in.
Yeah. See you later.
Thanks, guys. Have a good weekend. See you guys. You too. All right, any more questions from Zoom? Okay, all right, I'm gonna close it up, and so I'll see you next week.